Okay, yesterday we started talking about this little topic right here, but let's get into a little bit more detail. So if you had a slope that looks like this, what kind of slope is this? It's a positive slope because from left to right, you're going where? You're going up the hill, right? So that's positive slope. It's a positive slope. If you think about it, watch. Remember rise over run? If I wanted to get from one point to another, so if I wanted to get from this point to this point, I would have to rise. Okay, you can get there two different ways, can't you? Let's get rid of this, get rid of this. You could get there two ways. You could start here and go up and then go to the right, couldn't you? Or you could start from the other end and go where? Down, right? Because that's a rise as well. We think rise always going up, but rise could be going down. It would just be a negative rise, wouldn't it? Does that make sense? So we could go down and then to the left. It doesn't really matter which way we go. Which way you want to go? You want to go up and to the right or down and to the left? Either way is going to be rise over run. It doesn't make any difference. Up. Okay, let's go up. So, is that good? Is that good? All right, so let's go up. So that would be a positive, right, if you're going up. And if we go to the right, it would go right here. And that would be positive as well. What? Wait till that pass comes back. So watch, this is up and this is to the right. Everybody see that? So that's positive. And so rise over run would be what? Positive over positive. So what's positive over positive is positive. Okay, we could go the other way though too, couldn't we? We could have started from the top and gone down and then gone where? To the left. Let me go this way. There we go. So going down would be what? Negative, right? And then going to the left would be what? Negative. So what's a negative over a negative? It's positive. So either way you go from the bottom point to the top point, it's positive. Go from the top point to the bottom point, it's still positive, isn't it? The slope of it, the rise over the run, right? And so that's a positive slope. And you get used to it, and you just see if it goes from left to right and it goes up, it's positive. So let's do another one just real quick. Let's go back to white again. What if you had one that looks like this? All right, yeah, that's a negative slope. Let's find out why. Because if you went from one point to the other, this would be going what? What kind of rise is going from here to here? It's a negative rise, isn't it? And then this is what? It's going to the right, so what's going to the right? It's positive. So rise over run would be negative over positive, which would be what? Negative. So this is a negative slope. And again, how can we just look at it and tell without going through all that mess? Well, from left to right, what's our slant doing? It's going down the hill, isn't it? Everybody see that? All right. I mean, I've had some people say, yeah, but if I start here, I'm going up the hill. But remember what we're doing. We're going from where? From left to right. So from left to right, you're going down the hill. Agreed? What about this? What about that slope right there? Okay, you said zero slope. I heard somebody say no slope. Is it no slope or zero slope? Or are they the same thing? It's zero slope. Let's find out why it's zero slope. Okay, now watch. Remember, it's rise over run, isn't it? So rise over run. So if I want to get from this point to this point, we'll say from point A to B, instead of saying this and that. So from point A to point B, how far do I have to rise? I rise zero, don't I? I don't have to rise at all to get to this point. So I rise zero over the run, which is whatever. We'll call it just x since we're going along the x-axis. So what's 0 divided by any number at all? It's 0. Put that in your calculator. Put 0 divided by any number you want to put in there, and it's going to be 0. Everybody see that? All right, so this is zero slope. 0, that's my z, 0 slope. All right, or m equals 0. Everybody see that? Remember I said yesterday I talk about the skiing example? Well, think about this. If you're skiing, and this is the bunny slope. Who's been skiing in here before? Anybody been skiing? Like snow skiing? Okay, you ever go on the bunny slope? So when you first start off, actually the bunny slope isn't even this easy. Okay, usually it's just when you start walking out there, right, it's just flat. If it's completely flat and you just stand there, nobody pushes you, how fast are you going to go if it's just completely flat? You're going to go 0 if you're not being pushed or you're not pushing yourself, right? You just stand there, you're going 0 miles per hour. Would you agree? So that's a nice, easy way to think of it. Think of the slope. A 0 slope is flat. You're going, if it's flat, if it's horizontal, you're going 0 miles per hour. So it's a 0 slope. We're going to get to that in just, no, we're going to get to that in a second. All right, let's just deal with this one right now. We'll do it in just a couple of seconds. This is 0 slope. So a horizontal line has a 0 slope. All right, you can just look at it. If it's horizontal, it's 0 because the rise would always be 0, and the run, doesn't matter what the run is. Doesn't matter if you're going to the left or to the right. 0 over anything is equal to 0. All right, so that's a 0 slope. Now, Dominique will do what you were asking about. Look at this line right here. We'll put a point here and a point right here. What's the slope of this thing? Now watch. If you go from one point to the other, right? And again, I'll just call this AB. If you go from point A to point B, how far do you have to rise? Well, whatever that length of that line is, right? Okay, let's say the length of that line is 5. 5 whatever, inches, I don't care. All right, everybody with me on that? So the length of this line is 5. So how far do I rise to get from here to here? 5. Or if you're going down, you'd probably say what? -5. Or if you go up, you say +5. It really doesn't make any difference. Let's just say 5. Over, now watch, if I go from here to here, I've gone 5, haven't I? But now I got to run. How far do I have to run? I run 0. Right, I don't run or I run 0. Somebody have a calculator on them? Alex, put that in there. Put 5 divided by 0. See what your calculator says. Tell me. Oh, it even tells you why. Wow, your calculator's fancy. Right. It'll say error. All right, it'll say error. You put any number divided by 0, and you're always going to get an error because it doesn't exist. You cannot divide by 0. All right, it's not. The answer is not 0. I ask that all the time. Almost every year, somebody says, you know, if I say what's 5 divided by 0, almost every year, and I didn't ask you guys. Now I gave it away, right? That it's not going to be the answer. But a lot of people say it's 0. Is this 0? No, it's not. Let's go back in time real quick. Do you remember doing stuff like this? 12 divided by 3 is what? 4. Did your teachers ever tell you how to check this? 4 times 3 should equal 12, right? If you divide this right, then this number times this number should be the top. Would you agree? All right. What about, let's try 0. What's 0 divided by 3? Would we say 0 divided by anything was? Okay, let's do that test and see if it works. Okay, so 0 times 3 is what? 0. That works, doesn't it? Okay. Now let's take a number 3 and let's actually divide it by 0. Now some people say the answer is 0, but let's do that test. Is 0 times 0 equal to 3? It's not, is it? Okay. Now look, can you put any number here at all? Can you put any number and multiply it by 0 and get a 3? Or get any other number? You can't. There's no number that exists because any number that you multiply by 0 will always give you what? 0. All right. So can you divide by 0? No, you can't. All right. It doesn't even exist. There is no number that if you divide by 0, it even exists. All right. So what do we say about this? We don't say it's 0 slope. What do we say? We say it's undefined, or we could say it's no slope. All right. That's supposed to be an O right there. So no slope, or you could say it's an undefined slope, which means it doesn't exist. All right, it doesn't have a slope. For you guys that have gone skiing, has anybody gone on to the top? What are the colors for the hardest slope? They're black. They're black diamonds. That's right. You go up there, you might have a double black diamond or a triple black diamond or something like that. Whenever you see the black diamonds, you know it's going to be really, really steep. For those who've gone skiing, have you ever seen a slope where you get to the top, right? So this is me on skis. There, oops. No, I was supposed to be straight. Let's try it. So, oops. There's my ski right there, okay? That's me on skis. Have you ever seen a slope at a ski resort that you're allowed to ski down, an actual slope, that you're going to go here and it's going to go completely straight down like that? No. Okay, does it even exist? Does that slope even exist? No, it doesn't. Now, there could be a side of a mountain, but what do they usually have there? They don't usually have arrows saying, oh, go this way if you really want to have a exciting ride down. No, they don't. They say stay away. They'll have big barriers up or signs, don't go this way, right? And because that's not a slope, that does not exist. All right, so when you think of a vertical line, think of it when you're going skiing as no slope or undefined. This reminds me of something. Remember I said I was going to tell you a rappelling story? I'll try to make it real quick. This was me, and I was rappelling. I was in ROTC. You ever hear of ROTC? It's called the Reserve, I think it's Reserve Officer Training Corps. And it's like you're in college and you take classes, and if you do it long enough, you can actually join the Army or Marines or Navy or whatever you're in, okay? Whatever the ROTC is a part of. Well, we went out. I was in college in Virginia at Liberty, and we went to a VMI, which is a Virginia Military Institute, which is, I was not, but I was in ROTC. You can be in ROTC without actually being in the military, but I wanted to be in the military. I wanted to join the Marines. I had this friend who was even smaller than I was. I mean, I don't look that small now. I'm a little chubby now, but in college, I was a stick. I mean, I was like Jonathan. My son, John, you know him? John Hamrick. I was like him. I mean, that's the way I looked. I was that skinny, okay? So he gets that from me. And I was maybe a couple pounds heavier than he was, even when I was in college, okay? And so I had this other friend who was even smaller than I was, and he was in the Marines. He was telling me all these cool stories about boot camp and about getting yelled at and screamed at and all this thing. And I thought, man, if that guy can do it. And he was a little bit dweeby. I always thought I was kind of cool. I look back, and I definitely wasn't cool. But but anyway, but I looked at him. I'm like, man, if he could join the Marines, I could join the Marines. It sounds cool. And I saw him one time wear his uniform. I'm like, oh man, that looks so cool. I would love to have that uniform, you know. So I thought I'm gonna join the Marines, but I never did. I took tests. I went to the recruiter and took tests and everything else, but then a couple people kind of talked me out of it, like, nah, just go to college, get your degree, and then you can think about. And then once I got my degree, I was ready to get married and blah blah blah. Anyway, long story. I'm making it longer. So I never joined the Marines, even though I wanted to. But that's why I joined the ROTC, is because I wanted to do some military stuff without actually joining up, you know? Yes. If they accepted me? Yeah, I took a few tests, but I never signed my name that said now I'm formally signed up. But yeah, once you sign, you're committed, but I never did sign. Well, anyway, so I was on top of this. We went rappelling, right? And they had this one slope that went like this, and it was like dirt and trees and stuff. And you practice. You made this like little harness yourself, just out of a rope, just a single piece of rope. You ever do this? You ever see like rock climbing or like Great Adventure and stuff like that, where they hook you up? You know, they got all this and they tie you all up. Well, we had to make our own. It was called a Swiss Army seat or something like that, I think. Swiss seat, I don't know. And you did it, and you pulled it tight, so you're all tight, you know, and everything. And we practiced going down a hill like that. No big deal, you know. And you attach the rope to a tree or something like that, and you just go bounce, bounce, bounce down this hill. That was a piece of cake. Well, then we got up to this thing. This was complete straight up and down, completely vertical. Down the bottom were all these big old boulders. Big old huge rocks, okay, down here. It's all rocks down here, right? And so I'm going, and they say, let's see if I can draw. I'm a terrible, terrible artist. But they say, I can't even draw a stick person very well. There we go. And there's a rope, okay? So the rope was attached to this, you know? And you actually took the rope, you put it behind your back to kind of stop you. And it was pretty easy. It wasn't that big of a deal. So I'm like this, right? Well, I wasn't like this at first. I was kind of like my head was up here, my feet were here. And they said, you got to be perpendicular to the hill, right? Which means completely at a right angle. So I'm like, okay. Well, there's no lie. I was like this, and they said, no, let out a little more, a little more, a little more. No lie, I'm telling you, I was like this. Okay? I know I was like this, okay? And then all of a sudden, guess what happened to my feet? They slipped out, and I went like this. I went, yeah, boom. So now, here I am, okay? This is me. Well, I guess my arms didn't go that way. I don't know. Which way would your arms go? Maybe they did go the other way. I don't know. But this is me now, okay? And I'm hanging by a rope, okay? I'm still hanging on by the rope. And I'm completely upside down, right? The guys at the top, they're military guys. I mean, these guys are VMI guys. They're Army Rangers. They're tough dudes, right? They're freaking out, right? And all I see is my feet and these guys' heads looking over the top. These guys are up here looking over the top. And I was like, I was just so embarrassed. My face turns red when I get really embarrassed, and I could just tell my face was getting all red. And they looked over and they're like, "Don't move, whatever you do, don't move." And then like 5 other people, and then I see like 20 people, like all my classmates and stuff, they're all looking over and I'm like, "Oh my word." I was so embarrassed. They, "Don't move, we're going to come down and get you." So they're getting all ready to come down and get me. I'm like, there's no way I'm going to let these guys save me, right? So I kind of bounce back and forth, bounce back and forth. Finally, and they're like, "No, don't move." And there's all these boulders down here, right? And so I finally get my feet underneath of me like this, and then I went like bang, bang all the way down. And the guy at the bottom, he says, "Well, you had a little rough start, but you got down here faster than anybody else did." I'm like, "No, I was so embarrassed up there." So anyway, that was my rappelling. I didn't. Well, my butt hurt a little bit because when I fell, I fell like this, right, and my butt hit against the wall, and it was just a stone wall. So that hurt a little bit, but I didn't care. I mean, I went boing, boing, and I was down. Yeah, and usually guys were like this. Usually guys took like 5 or 6 or 7 times to get down, but I went as quick as I possibly can.
We should have a shout out to Miriam.
So that's my, hi Miriam, if you're watching. I hope you enjoyed our story. So anyway, that's my story. Andrew. It was pretty high. It was at least 60, 70 feet, I would say, probably. It was high enough. I was not crying. No, I wasn't crying. So it was definitely high enough. It was definitely high enough where if I would have actually fallen, I would have definitely died for sure. I mean, it was no clue. But so that's what I remember. So when I think of a vertical line and no slope, this is what my mind always goes to, is being upside down, going straight up and down like this.
Why would you want to do that? Because like.
Oh, it was fun actually.
No, but like you're making your own harness thing, so if you
right,
fell,
right.
you die.
Yeah, but they checked it and stuff, and I just assumed they knew what they were doing. Oh, get this. These guys, these ranger guys, they did this thing after this event was over. They said, "Do you want to see us do Australian rappelling?" Right? And I was like, I've been to Australia, but
You like Australia.
I like Australia. I lived there for 2 years, but I didn't know what Australian rappelling was. No lie, this is what they did. And they didn't tell us what they were going to do. They got all hooked up, and these were like Army guys, VMI guys. And they just started running, like way back here. Run. And they full sprint. And they just jumped. Woo! Like this. Head first. No lie. Head first. They jumped. And I don't know how they did it. But then they would bounce once. They'd bounce once against the wall, right, like with their feet, and then they would get down the bottom. Oh, my goodness. I thought I was kind of crazy for just doing regular rappelling. But these guys were nuts. Those Rangers, man, they're the real deal. And it was pretty...
Oh, my goodness. Like, it was like on the back.
No, they had harness. They had a rope. They had a rope and stuff, and, and it was... Yeah, I've never looked it up. Look it up.
They jumped off a bridge, and underneath there was water.
What?
Yeah, there was water.
We'll look it up some other time. We got to do some.
Beneath the bridge, and they were bungee jumping off a bridge.
There were rocks in there too.
No, that was it. I told you all my stories. I have no more stories to tell. All right, let's do this. Enough story time. Let's do some of this. Now, what? Oops. Let's do this. Watch
the next
this.
lesson?
No, it's the same lesson. It's just stuff we didn't get to. But I always have to tell my rappelling stories because it brings back fond memories. Now look at this. These 2 lines. Now I copied and pasted. So what do you think might be true about these 2 lines? They're parallel. No, they're not perpendicular.
I mean, parallel.
Parallel to each other. Okay. Now, if this slope right here, let's say we counted, and I don't know, what would this be? This would be like -3, and then this would be, we'll say -7. Okay. So what's the slope of this line right here? It's 3/7. That's right, because negative over negative, it's a positive slope, so it's 3/7. Okay. Now, if this line is parallel to this line, what's this? Without me doing any math at all, what might you think would be true about the slopes? They're going to be exactly the same, right? I copied, pasted it, just moved it down a little bit, right? But I didn't change the slant of it at all, did I? All right, so if they're parallel, that means they're slanting in the same direction, which means they have the same what? Slope. Okay, so parallel lines have the same slope. Write that down because this is going to be very important. You probably did this in Algebra 1, but a lot of people when they come here, they're like, yeah, I remember doing this in Algebra 1, but I I never did know how to do it even back then. So hopefully we'll learn how to do it here. So parallel lines have the same what? Slope. All right, so they have the same slope. All right, that's pretty easy to remember, isn't it? So if I tell you the slope of this line right here, if it's parallel to it, it's going to be the exact same slope. Make sense? All right. Now, what's the other type of lines we have, Caitlin?
Perpendicular.
Perpendicular. Okay, so
My name's gonna be on the video.
wow, you're going to be famous. All 3 people that watch it are going to hear it. So. All right, so look at this. If these are perpendicular to each other, actually, I could keep this line could keep going through if I wanted it to. All right, so here's 2 lines that are perpendicular to each other. Now let's take a look at the slopes. First of all, what's the sign, S-I-G-N? What's the sign of this slope right here? We'll call this line L and line M. So line L, what's the slope of line L as far as being positive, negative, 0, undefined, whatever? It's positive, isn't it? From left to right, it's going up. Okay, so that's a positive slope. What about line M? It's negative, okay? Now, if you look at it, well, I didn't draw it that great. Let's see if I can do this. I don't know if I can do this or not. Aha, look at that. That's a little bit better. Let's make it a little more extreme so I can see what's going on. See, I couldn't do that on a whiteboard, could I? All right, look at this. Look at this slope right here of line L. Compare it to line M. Do they look like they're the same slope? No. Now, look at it. This is way steeper, isn't it? Okay, than what this is. Look, this has real long y compared to a short x. This has a relatively short y, right, to a longer x. Would you agree? So they're not the same at all, right? What they are, look, this slope is positive and this slope is negative. If this slope right here, let's just pretend, I'm just making up a number. Let's say the slope of this line L was 2, right? 2 over 1. Then this slope right here is the complete inverse of this slope. All right, so it's not 2 over 1, it's what? It's 1 over 2. But if this one's positive, what's this one? It's negative. So the slope of line M is negative 1/2, and the slope of line L is positive 2. So here's the phrase that I like to use a lot. We say, when we have 2 lines that are perpendicular to each other, we say the slopes, let's do this, the slopes of perpendicular lines are, and people could say different things, but this is what I usually say. I say negative reciprocals. Reciprocal. Okay, of each other. Okay, so the slopes of perpendicular lines are negative reciprocals, which means what? I change the sign. When I say negative, it means if it was a positive slope, now it's negative. What if it was a negative slope? Then the other one is positive. Okay, it's the opposite of it. And it's the reciprocal. What's the reciprocal of 2 over 1? It's 1 over 2. This was positive 2 over 1, so this is negative 1 over 2. So when you have lines that are perpendicular to each other, that's the relationship between those 2 slopes. Do you remember learning that in Algebra 1 last year? No? Does somebody? Okay. Did you have this? Did you learn this? Okay. So anyway, that's an Algebra 1 topic, but we'll definitely hit it right here. So what if we had this? What if I had a slope? I'll put 1. So the slope of line 1 is 3/4, okay? And line 1 and line 2 are perpendicular to each other. So what would the slope of line 2 be equal to if the slope of line 1 was 3/4? It would be negative 4/3, right? We don't just take the reciprocal, we take the opposite sign, okay? The negative reciprocal, all right? So that phrase right there, I really want you to understand. It's the negative reciprocal. So let's do another one. What if the slope of 1 was negative 1/3? What's the slope of line 2 going to be? Right, positive 3 over 1. Or you could just say positive 3, couldn't you? Make sense? All right, pretty simple, right? So if the slope of one line they give you, then the slope of the other line is going to be the negative reciprocal of it.
How come the second one is the negative?
Because it was negative. It was negative. So when I say negative reciprocal, what does that mean when I take the negative of something? I'm taking the opposite, right? The opposite sign of it. But I like to use that word negative reciprocal. So I take the opposite sign and I flip it. So 2 things you have to do. So if the lines are parallel to each other, what's true about the slopes? If the lines are parallel, slopes are,
Negative.
if they're parallel, if the slopes are parallel, slopes are the same. Okay, let me use this. Watch. Here's two lines right here. If those slopes are parallel to each other, what's true about, if the lines are parallel, what's true about the slopes? They're the same. Okay, what if they're perpendicular? Then the slopes are the, what's the word?
Negative reciprocals.
Negative reciprocals. Okay, say negative reciprocals. Right? It doesn't matter if it's like this or whatever. Okay, you follow me? If they're perpendicular, that's the relationship between them. All right, so let's do they have any examples in here? Tell you what, let's do one of the problems you might have had to do. Look at number 28. Did you try number 28 last night? Did I? Okay, good. Well, let's do 28 because then you didn't have to do it. But it's like the ones you did, right? So that's 1, 5. B is 4. That's an A. And then C is 9, negative 10. Write this down. We'll use this problem as an example. And then D is negative 6, negative 5. All right. Yeah, 4 points, okay? It says, determine whether line AB and line CD, determine if they're parallel, right, or perpendicular, or neither. So how in the world do we do that when they just give us these points? Do we actually have to graph it and look at it? Not necessarily, because all we got to do is look at their what? At the lines, no, not just points, slopes, at their slopes, okay? Let's find the slopes. So I got to find the slope of line AB. So let's find the slope. I'll put a little AB right there. Is that all right? Does that make sense to you? M is slope, the slope of AB. So how do we find the slope? It's the change, remember that? The change in y over the change in x. So that means when I say the change in something, you just subtract them. So let's do AB. So subtract the y's. What numbers do I have? 5 minus 4. Now, if I go the first one minus the second one, I got to go in the same order with the other number, okay? So if I go 5 minus 4, what am I going to do for the y? Or for the x, I'm sorry. 1 minus 4. Everybody see that? And that gives you what? 1 over negative 3. I can put the negative out in front, can't I? All right, so that's the slope of AB. So now I got to find the slope of CD. So let's find the slope of CD. So the slope of CD. Do the same thing. Change in y, so it's negative 10 minus what? Not just 5, minus negative 5, which will be a plus, won't it? And then we do the x. Remember, the y goes first, and then the x, you do the x next. So that's 9 what? Minus negative 6, and that goes to a plus. Let's see what we get. Negative 5 over, what's that? 15, right? But we reduce this. 5 goes into that once, it goes into that 3 times, so it's negative 1/3. So look, the slope of AB is 1/3, and the slope of CD is, I'm sorry, negative 1/3, and the slope of CD is negative 1/3. So what does that tell you about being parallel, perpendicular, or neither? They're parallel to each other. How do you know they're parallel? Because the slopes are what? Are the same. So we say that they are parallel. All right, because the slopes are exactly the same. And that's how you do those kind of problems right there. Yes? Doesn't matter which order you subtract them, but you have to subtract the y's in the same order that you subtract the x's. All right, look, I could have done this. I could have said 4 minus 5. But if I went 4 minus 5, I'd have to go 4 minus 1. Do you see that? And if you look at this, what's 4 minus 5? It's negative 1 over 3. It's still negative 1/3. Okay, so what doesn't make any difference as long as you subtract the y's and the x's in the same order. All right, and then you're fine. I always like to go the first one minus the second one. I don't know. To me, that's just a little easier, don't you think? And that's how you do those kind of problems. It's not too hard, is it? No, it's just basically finding the slopes. It's a lot of practice. You had a lot of practice in this lesson to find the slopes. Yes. Isn't what? Say what? Yes, that's my plan. Okay. Is I want you to now listen to what I want you to do. I had you do what? To 39? Okay. I'm just going to change a little bit here. So I want you to do 34 to 39, but I want you to do throw in the evens as well. That's only what, 2 more, 3 more problems? It's only 3 more.
So just do 34.
So 34, 5, yeah. So I already assigned the odds. So what you're doing today is 34, 36, and 38. But, well, I want you to make sure you know how to do those other ones, okay? Because I don't know if you realize, like all those ones before this with the parallel and perpendicular. I want you to basically do everything to 39, but include these as well. Okay, throw those in there as well. All right, listen. I want 11. What did it start with? 11 or
181 and 182.
13? Started. It was 13 to 39. Okay, so I want all that. All right, but a lot of you, listen. A lot of you didn't finish it because you didn't really understand that parallel perpendicular thing, okay? Some of you did, all right? So finish what you couldn't finish last night, but add these 3 to what you were to do last night. Everybody see that? Okay, so finish what you were supposed to do last night, and then add those 3 to it, and that's it. Yep, start working on it now.
Graph them to check them. Do we have to?
No, if it says graph it to check it, don't worry about that. That's too much work, okay?
We don't have to.
I'm sorry.
Yeah,
Well,
I know. I graphed everything.
So did
That's
I.
all
How
right.
I figured
It's
it
good.
out, and I still got 'em
It's
wrong.
good practice for you. It's good practice.
Oh, I figured it out.
Let me ask you this. Let me ask you a question. Is there anybody that you came in today and you didn't know what they were talking about by this, but now you look at it and you're like, okay, I can do that now. Does anybody feel like that? Okay, good. A few of you. Right. To do number 27? Yeah, let's take a look at it. Oh, my. I'll tell you what. We'll do that tomorrow.